Hey everybody, it's Tony from Adafruit, and I'm going to do another stream on using Bluetooth Low Energy with the Raspberry Pi. So this is the third in a series, and I think this will probably be the conclusion so far. I'm sure I'll come back and do more Bluetooth Low Energy stuff, but we'll kind of try to tie everything together and make a custom Bluetooth Low Energy device, or at least a custom service that exposes some characteristics, and really show you how to use Bluetooth Low Energy to send data and expose interesting sensors and things like that. So let's jump right in and we'll go to the workbench. Oh, and also I changed, you don't see the fancy animated background. I'm trying to kind of tweak things a little bit. The animation took a lot of CPU, so hopefully this will make the stream a little bit smoother. But we'll jump to the workbench shot and we'll see what I've got here so far. And let's see, let me put my face down in here. So basically same setup that I've had before. So I've got a Raspberry Pi 3. This is, the new one. It has Bluetooth Low Energy and Wi-Fi built into it. So really handy, pretty much just all in one, and you're ready to go for Bluetooth projects. And then right here, this is the Feather M0 Bluefruit. So it's just the little SAMD21 Cortex M0 Feather, and then it has the Bluefruit radio, the NRF 51822. And I'll show you some neat things that we can do with this. So it's an Arduino compatible, and I think I've talked about it a little bit before, but it's got the little Bluetooth radio, so we can expose different devices and things like that over Bluetooth. And then this right here, this is a little DHT22, or I think it's an AM2302. It's a temperature and humidity sensor. Real low cost device, but nice and easy to use. Just connect to the Arduino, use the library, and you can get the temperature and the humidity values. So what I want to do is I'll walk through basically building a custom Bluetooth Low Energy service on the Bluefruit right here that exposes the humidity and the temperature data, and then from the Raspberry Pi we'll use its Bluetooth radio to read that data, and I'll actually show a little Python library that I wrote that's hopefully pretty easy to use and lets you get data without maybe having to use like Noble and Node.js like I showed in the last stream. And they're kind of trade-offs to both that I'll talk about, why my library might be more interesting, why you might want to use it in some cases, and maybe use Noble in other cases. So let's jump in and let's look at the desktop real quick. So let's jump to this view here. And basically, so I'll start with just kind of talking through, let's look at the device first, so the Feather Bluefruit, and we'll turn that into a little Bluetooth Low Energy device that has our temperature and our humidity sensor data. And then we'll go from there and connect to the Raspberry Pi and see how we can write some code to read that data. So just to start with, I'll start with just some interesting examples, and we'll kind of use these as the building blocks for what we want to do. This is the guide for the Feather Bluefruit LE, the M0 Feather, and it gives you all the details on how to use it, how to set up the Arduino IDE, so definitely go here. Now the interesting thing is that this guide tells you all about these AT commands, and so this is a special set of commands that you can use with the firmware on the little Bluetooth radio on our devices, and you can do lots of interesting things. So there's a lot of examples in the library for things like using the UART device so that you can send and receive serial data. That's what we used in the previous video. So I did a little example of just sending a string like on and off and receiving that and being able to change the state. But there are also a bunch of commands that let you actually customize the Bluetooth services that are exposed by this device. So by default it exposes the UART service and a few other services, but you can actually add your own services. And actually, before I forget, let's put in the workbench up here too, so you can kind of see. I guess there won't be much going on. There's nothing like LEDs flashing, but you can at least see it. So in the guide, if you go down to this AT commands section, and all of the Bluefruits have this AT command. So it's the Feather M0 is the one that I'm using, but there's the Bluefruit Spy friend that you can connect to any Arduino using a Spy connection. There's the older UART device that uses just a UART connection. There's even the BLE Micro that we had that's kind of the precursor to the Feather, so it's a little Arduino compatible with the Bluetooth radio on it. So any of those support these AT commands. And all of the guides have a really good explanation about exactly which commands are available, and so you can go through and see a lot of these commands. Now the ones that I'm going to look at are the Ble Gap commands, and if you go back to the first video that I did in this series, I talked about the GAT and how it's this generic architecture for creating services, and services have things like characteristics that define the data that's inside of them. And so you can actually use some of these AT commands to modify that GAT hierarchy and do things like create a service and create a characteristic. And so if you read through this, it talks about a lot of the commands that are available. So there's things like an add service command here that lets you say, okay, I want to create my own custom service. Then there's also an add characteristic command that says, okay, now that I have a service, it has some characteristics I want to define. And so you can do that. You have to give all of these a GUID that says, here's the unique ID for this, and you can tweak a few parameters for that. Now the way to get started with this is in the Bluefruit library. So I'm looking at an example right here. This is, I just installed the Bluefruit library, and it's the heart rate monitor example. And actually we have a little mention of it in the guide here too. So if you go to the heart rate monitor example, so this talks about it. So in Bluetooth Low Energy, there's actually a standard service for a heart rate monitor. It's like something you might wear if you're like working out, or maybe like a fitness monitor that you have that measures your heart rate and then sends it to like a mobile phone. And so all of that's defined using the special heart rate monitor service. And this example kind of walks through how it does that. And so it's not built into our library natively. It's like we don't have a heart rate monitor object that you can go and create. So we use these AT commands to create the heart rate monitor service and the characteristics, and then send it data. And so if we open up the example here, I'll just kind of walk through it briefly, but it's very similar to all the other Bluefruit examples that we have, where there's a bunch of boilerplate at the start to just create and initialize the Bluefruit connection. And there are lots of ways to connect the Bluefruits. Like I said, you can use a UART connection, a SPI connection. So for this board, you have to use the SPI connection just because that's the way the radio is connected to the microcontroller. But once you get through that boilerplate, basically it has a few global variables here that hold the service ID and the characteristic ID. So once you create a service, you get back a little ID that you can use to modify that service later. And if you go through the setup code here, a lot of it is just initializing the Bluefruit at first, but then we start to get down to like these commands here where we're saying, okay, let's change the name of this device. And so you can actually see we're doing this BLE send command check OK function, and we're sending it a custom AT command here. So we're actually sending it this AT gap dev name equals Bluefruit HRM. And if you go back to the guide, the AT commands for this, you can actually see in the BLE gap there's the name, so dev name. So this will change the name of the device. So by default, the device advertises itself as Bluefruit friend, or I think Bluefruit LE module, but you can change that. So you can say, okay, I want to make this Bluefruit HRM heart rate monitor. So that's kind of cool. And you can see how, there's no library function yet that you can call that says like change the name. That might be a nice thing to add later. But for now, when you want to get down to that lower level, you can just use this send command function and give it any AT command, and then you can check that you get a good result back from it. So we'll go and the code, it just changes the device name, and then we get into the real meat of defining the custom service here. So we call this AT command the GAT add service, and in this example we just pass a little short UUID. So this is like a 16-bit UUID because this heart rate monitor service is predefined by the Bluetooth special interest group. So we're just kind of using that preset one, and I'll show you when I create a custom one kind of how we change this to use a larger UUID. But basically we create the service, and this will give us back this service ID value. So we need to hold on to this because this is kind of the handle for how we identify that service. And then we can go through and we can actually create characteristics. We can add characteristics to that service. So again, it's just another AT command. So we're calling this GAT add char command here, and we pass in the UUID that we want to give it and a few different properties about it. So if we go back to the guide and we look at the different AT commands, so the add service command, like I just mentioned, this one, it just takes in the UUID that you want to use, and you can pass either a long one or a short one. In most cases, you're probably going to use a long UUID if you're creating your own custom service. Unless you've like paid money to the Bluetooth Special Interest Group and gotten your own little short code, you're likely going to have to create your own long one. But it's okay because it's just a random GUID. So you just create a GUID and you're good to go with it. So that's all you do to create the service, and then to add the characteristic, it takes a few more parameters. So it takes in, again, the UUID that you want to set, and this can be a short or a long one. Then it takes in this properties value, and so this is how you define what properties this characteristic has. If you go back to the first video when we looked at some Bluetooth Low Energy devices, you saw how each characteristic can have a different property. Like some of them might be readable, some of them might be writable, some of them might be readable and they might be able to notify you when they change. And so this is just a bit mask, or you can pass like different bits to flip on some of those attributes. So you can make something readable or writable, or this notify bit says that when it changes, you can be notified, like you can subscribe to changes on this attribute. So you define the properties for this, and then you can pass in some values to say, what's the range of values you might see, or like the minimum and the maximum length of data. So as far as the Bluefruit firmware is concerned, it's just going to treat the data for this characteristic as a string of bytes. So we can say, this might have like a minimum of 1 byte and a maximum of like 20 bytes of data that we can pass to this. So it just kind of lets you say, okay, I expect this characteristic to be maybe a small one or a large one. And then there's an initial value you can also assign to it to say, okay, when you first get initialized, here's what your starting state should be. And by default, this is a value like 0. And then you can go back and change this later. And the way that you can actually change a characteristic is this Dht care command. And so this one just takes in a couple parameters. You have to pass in the characteristic ID. So after you call this add characteristic command, it's going to return back a number that represents the ID of that, so that you want to save that. And then when you want to change the value, you call the Dht care command, you pass it that ID, and then you pass it the second parameter, which is the new value that it should have. So this could be like a string, it could be a list of bytes, it could be like an integer value, and then that's really all you need to do. So you set the value, and then the Bluefruit firmware and the NRF 51822, it'll take care of remembering that value, and if a device connects to it and asks for the value of that characteristic, it'll send it back. Or if you change that value, like when you call this Dht characteristic command, if something has subscribed to changes, they'll be notified that it's changed. So it's really easy from the Arduino side in that you just define your service, you add your characteristics, and then you just set your characteristic values, and that's all your sketch really needs to worry about. And so if I go back to the heart rate monitor code, you can see, so it adds the characteristics, and then one important thing, after you add services and characteristics, you need to do a little reset of the board, so like a software reset, just to make sure that it reads in that new state and exposes those characteristics. But then in the loop, it's really just picking a random value, in this example, between 50 and 100, and then it's sending a special Dht command, the Dht care command, and it's just sending the value that it got there. So you can see it kind of constructs it and sends it in multiple calls. So we start by saying, okay, first start with the Dht care command, and then pass in this characteristic ID. So this was the output that we got from creating this heart rate measurement characteristic. So you can see the function that we're calling is the send command with int reply. So this expects to send an AT command, see that it succeeds, and then also see that it returns an integer value back to you, and then it just saves it in this value here. So we're passing in that value that that ID that we remembered, and then we're just passing in some bytes down here. So we're using this kind of byte string or byte array format where you pass 2 hex characters and then a dash and then 2 hex characters, as many hex characters as you need to define the bytes in this. So we send a couple bytes basically here. And that's all this code does. So it just picks some random values and just advertises them and sends them out to this characteristic value. And so that's maybe not the most interesting heart rate monitor because it's just picking random values, but it's showing what you can do to create these Dht characteristics and services. So what I did is I actually took this example and I modified it slightly. So I created this Ble Dht example, and so this is using that DHT temperature humidity sensor. So I took the example for the DHT library, and it's really easy to use. You just create a DHT object, you just point it at the pin that it's connected to on the Arduino, and then it can read the temperature and the humidity from there. But what I did is I took that heart rate monitor example, and then I created my own characteristics and services. So right here I defined some UUIDs, some unique IDs or some GUIDs, and these are long, 128-bit long UUIDs because these are my own custom services that I'm making up. There's no DHT sensor service that the Bluetooth special interest group defines, so I'm creating my own service basically. And the way that I got these, it's really easy. Just search for a GUID generator online, like the first Google hit I went to, and you can literally just click a button and get some GUIDs back. It's just a big random number basically, but you do want to make sure that these are unique values. You don't want to use the same GUID for all of these, and ideally you don't want to have like a conflict with, if you've got multiple services you're defining, give each one a unique GUID. So I've copied out those GUIDs. Now I put them in this special format where basically the GUID generator gives me kind of this hex format, and I need to actually break that down byte by byte and put dashes in here. So like I said before, you put each byte as 2 hex characters and then a dash in between there. And so that's just the format that the library expects. But I define all of these GUIDs. So I have one for my custom service, my DHT service. I have one for each of the characteristics then. So for my temperature sensor and humidity sensor, that's part of that DHT sensor. So basically 3 GUIDs total that I need here. And then I just do the same boilerplate that I had before. Like now I've also added the initialization for the DHT sensor, but exact same code that I had before with the heart rate monitor sensor. And really the only thing that I changed is the setup for my service. So now I'm actually changing my command. So I'm still calling that GAT add service, but I'm passing this UUID 128 parameter. And so this is how I send in a long custom UUID value. And what I'm doing here is I'm just concatenating 2 strings. So this is kind of a handy little thing that C and C++ supports, where if you just have 2 string values here, like if I had, foo and bar, it's just going to concatenate all of these strings together as if I had, one long string that looked like this. So it's kind of a handy way to put in like some custom strings, but also have maybe some boilerplate in front of them. So I've got my add service command, and then I'm passing in that long UUID value that way up at the top I defined here. So it's just going to paste in this value basically into here. So I create my service, and then I create my characteristics just like I did in the heart rate monitor example. But this time again I tweaked it, so I'm using UUID 128 because I've got a long UUID now. And then my properties I also tweaked a little bit, so I'm using property OX10. And so if I go back to the guide here and we look at the property values, so you can see that OX2 means that this is a readable property, and then OX10 means that this property can be signed up or subscribed to be notified when it changes. And you can combine both of those, so these are just bits that you can flip on. So if I send a value of OX12, that means that I can notify, I can subscribe to this, and then I can also read it explicitly. And if I wanted to make it writable, where like something could connect and actually change this value, I could flip on the bit that changes that, for example. But in this case, these are just read-only attributes. I'm just letting you read the temperature and the humidity values here. So that's the meaning of this OX12 right here. Then I also tweaked the minimum and maximum lengths. I made it between 1 and 10 bytes because what I'm going to do is I'm going to send the temperature and the humidity just as a string value, which like basically I take the floating point value and convert it to a string. So this could be a number, and I mean in practice the temperature should only range from like -32 to like 100-ish or so, at most. The humidity is just a percentage, so from like 0 to 100. So at most I shouldn't have more than maybe 6 or 7 characters in length here, and the sensor only has like maybe 2 decimal places of accuracy. So just something to think about, that you do need to be careful about setting how much data you can send here. So I just create those characteristics and have the exact same code. In fact, I forgot to say it, so we'll say oh, actually here, so this little bit of code right here, I don't actually need this, but this changes the advertising packet that will be sent out by the Bluefruit device. And so in the heart rate monitor example, it actually changes the advertising data to say, hey, advertise the heart rate monitor service. I don't really need that. I could make it advertise my custom service, but it's maybe more than I want to do, so I'm just going to pull that little block of code out. But it's just like the heart rate monitor service as far as how this runs, does the software reset. And then in my loop, I'm just doing some real simple code here. I'm taking a humidity and a temperature sensor measurement from that DHT sensor, and then I'm calling this little set characteristic value function that I created, and just passing in the humidity and the temperature that I want to set. And I'm also passing in the characteristic ID. And so this is the value that came back from calling the add characteristic commands up above. And so in this set characteristic value function, I'm just constructing that gat_char command that you saw before. So I'm passing in the characteristic ID, and then I'm also passing in the value that's passed in. So this takes in a floating point value, and I'm just using the print functions in Arduino. So I'm printing out that floating point value. You can pass in a precision value also. So this is how many digits after the decimal place should be printed, and I just defaulted 2 because this sensor doesn't have a ton of precision. So for example, if it has a humidity value of like 89.92, then this will print out 89.92 as a string. And then I just call this wait for OK to make sure that it gets an OK response back, that it sees that it succeeded in updating that characteristic value. And then I just wait 2 seconds and loop again. So real simple code. It's just reading the humidity, reading the temperature, and then setting that characteristic value and just doing that forever in a loop. So let's load this up on my Bluefruit device here. So just going to do a quick little reset on it. I noticed there's some funkiness with Linux where sometimes it doesn't like to upload to the device automatically. So if you double press the reset button, I think like I mentioned before, that puts it manually into the bootloader mode, and then I can upload to it. So it just uploaded, and now let's open the serial monitor. And so we'll see in this example, it's doing all this initialization, and I'll kind of step through what's going on here. So we'll turn off the scrolling. So it has a debug mode turned on right now where it's showing all of the AT commands and the responses that it gets back. So at the very start it says, okay, perform a factory reset. And so it's calling this AT factory reset command, and then it's getting back an OK response. And so then it gets some info and prints out, what's the version of the software, the firmware and stuff that's running on the Bluefruit device. And then you can actually go down and see, here's where we create our DHT service. And so here's that gat add service command, and you can see the full command. So we're sending that UUID 128, and here's that custom UUID that I defined in the sketch. Here's where we create the characteristic. And then you can also see in all of these, we're coming back, when we add the service, it returns a value of 1. And when we add the first characteristic, that returns a value of 1. And then we add the second characteristic, and then that returns a value of 2. So that's the unique ID that identifies that characteristic in that case. And so then we do the software reset, and now you can actually see those gat add char commands. So this is when it has a value for the humidity and the temperature. It calls that gat char command, and it's passing in, for example, here it's saying, okay, so characteristic 2, which is this one up above, so that's my humidity characteristic, here's the current value, 53.5. And then if I turn on the scrolling again and we jump down to the bottom, you can see every 2 seconds it's just taking a new measurement. And so if I take the sensor and if I breathe on it, then we should see it change. And it takes it a second or two for it to update. But you can kind of see, okay, so now my humidity just jumped up to 81, 86, so it's gone up a little bit. So that's kind of cool. So we can kind of see I've created my custom service, I've got my custom characteristics. Now let's see what's actually being shown over the Bluetooth radio. So I'm going to run my little Bluefruit desktop app on Linux this time. So I'm going to run this, and this is just from my Linux machine. And again, this is built on Noble. Go back to the previous video, the part 2 video, and you can see a little bit more about this program. So it's scanning for devices, and you can see here's my Bluefruit DHT device. And so it looks like the name change worked. And I didn't really show this, but in the example, I changed the name of my device to Bluefruit DHT using that gap dev name command. So we can see, okay, cool, we see our device. So let's click it and connect to it. And it's going to connect and find all the services for it. So this is showing all of the services on here. And if I scroll all the way down to the bottom here, there's this special service here, this 91B30, ends in 750. Now if I go back to my sketch and we look at the GUIDs that I defined, look at that, there's the GUID that's my custom service. So this is pretty cool. It's showing us that my device has this new custom service, and there are two characteristics here, and both of those characteristics have the UUIDs that match the custom ones that I set before on here. And then the cool thing is this is actually showing me that for both these characteristics I can either explicitly read them or I can sign up to be notified when they change. And when I click this little read, it's going to read the current value of this characteristic. So the 907 characteristic, which is the temperature, so it's showing that the current temperature is 69.44 degrees, and that's in Fahrenheit. And so if I click read again, we'll see, okay, it changed a little bit, 69.26. And then the other characteristic, this should be the humidity, so it's like 64.6% humidity. And so I can read these, and what's happening is every 2 seconds my sketch is updating the characteristics. So you can see over here in the serial output, and then after it updates it, I can do a little read and get the current value for these. So this is pretty cool. Like, we've got our own custom Bluetooth device effectively. We've created a DHT sensor Bluetooth service, and we have a couple characteristics that expose the data from that, the temperature and the humidity from there. So that's pretty powerful. I mean, really, we're creating our own custom Bluetooth Low Energy device this way. And we're using that GATT architecture that lets you define these custom services and characteristics and properties on them. Another way you could do this, you could just use the UART service, the serial data, effectively over Bluetooth. And even with Bluetooth Classic devices, there's a serial profile. And I could take my temperature and humidity data, maybe turn it into like a comma-separated list, a string of values, and send that over a serial connection. And that would work. That's perfectly fine. There's nothing wrong with doing that. But it's more work for your client, because now you've got to parse out that data, and you have to know that, okay, this value is temperature, this value is humidity. I have to look at, figure out what's my comma separated data and do that parsing. So it's a little trickier. I mean, we can use that GATT service that Bluetooth Low Energy exposes and explicitly have an attribute that says, here's my temperature, here's my humidity. Then anyone else could, as long as they know my schema for this service, they could write some code that talks to this device and says, okay, I'm going to look for this special DHT service, and I know that it should have these two characteristics that define the temperature and the humidity, and it can read those values and get them. So that's pretty powerful and interesting, and something that I haven't seen a lot of good examples of yet. And so it's a really good, interesting way to use the Bluefruit devices is to explore creating kind of custom Bluetooth devices like this. So the next thing I wanted to do then is, okay, let's write some code now to interact with this device. Like in the part 2 video that I did last week, I did some code with a library called Noble that uses Node.js. And it's a really great library, very full-featured, does a lot of great things. But this time I wanted to use a little Python library. And this is one that I created a little while back. And it's a library to talk to Bluetooth Low Energy devices. And it supports all the different platforms. So it supports Mac OS X, it only supports Mac OS X and Linux right now. It doesn't support Windows yet. So if you want to use Bluetooth Low Energy with Windows, Noble is really your best way to go right now. But I've written this basically to use those two libraries, and on Linux in particular, I wanted to do it using a special interface that Blues exposes. It's this dbus interface, and dbus is a special thing in Linux where it's basically a message bus so that two programs can talk to each other without having to be tightly coupled to each other. They don't have to link against each other's code and call functions, that they expose. It's more of the operating system exposes this message bus that a program can send data to a topic, and then another program could listen to that topic and receive data. So if you're familiar with MQTT and that protocol, it's very similar to that, but just think of it as a local MQTT service where programs can create different services and topics and things inside of a tree and subscribe to them. And that's, from what I understand, the official way that that Blues wants you to interact with its services and with Bluetooth devices, is by using this dbus hierarchy. And a lot of the tools that they provide are actually just using dbus internally. So I wrote a little Python library that uses that dbus interface and then interacts with Bluetooth Low Energy devices. And then on Mac OS 10, it actually uses the Mac's custom Bluetooth library. I think it's Core Bluetooth. It's a whole set of like Cocoa runtime kind of classes and things. And it hides all that from you so that you just interact with these custom Bluetooth classes for this. But there's a guide, and I'll link to all of these in the description when it's up on YouTube. But you can check out this guide. It talks about this little Python library. And it's pretty straightforward to use it. So I have it set up, and you can go through the installation, and it just tells you on a Raspberry Pi, you need to be running Blues. Like, go back to the first video in this series where I show how to compile and install Blues on the Raspberry Pi. So you have to be running Blues, and you have to run it in the experimental mode that I showed how to do, because again, that turns on the dbus interface for all this Bluetooth Low Energy stuff. But once you get that set up, it's a pretty simple install. You just clone the code and then run the setup.py install. And so I've done that ahead of time on the Raspberry Pi. So I've connected to it, and I've, we'll clear out of here. So I've installed the library, I've installed Blues, I've set Blues up so you can see if I run systemctl status of Bluetooth, that my Bluetooth service is running, and it's running with that experimental flag. So Blues is running basically. I've installed the library, and I'll show you some of the example code that comes with the library. So one of the examples here is this low-level.py. And basically this is an example of interacting with a Bluetooth service and characteristic that just has some custom UART or some custom GUID value. So some of the other examples I have are talking to a UART device, and there's some nice little helper classes I added to the library that make it a little bit simpler so that you can just call a function to read and write data with a UART. But in this case, I've created my own custom Bluetooth service and characteristics, so I need to be able to interact with those at a low level. So this low level example, it just says, okay, it deals with talking to a UART device. And so it looks at, here's the UUID for the UART service, and here's the UUID for one of the characteristics that it exposes. And then the code goes through and it initializes the library. So you have to call this getProvider function to basically say, okay, figure out what platform I'm running on, whether this is Mac or Linux, and then set up the dbus connection on Linux. And there's a whole lot of stuff that goes on in the background because dbus, the typical way you interact with it is using a library called glib or GTK, and that means you have to have this message loop in the background. And so there's all this ugly stuff that goes on that I really try to hide in this example, because ultimately I want this to be really simple and very procedural. So like you saw the Node.js code that I looked at in the last video with the Noble library, it's very asynchronous. You call a function, you say start discovering services, and when you find a service, then call some callback. But I wanted to see if I could do a library that's a little more procedural so that it feels more like I'm calling a function, it's doing some stuff, and then it returns when it's done. Because that lets you write a little bit simpler code. It's not necessarily better. I mean, it's actually less efficient because, while you're waiting for something to finish, your code is just doing nothing. It's just spinning there in the background. But it's a lot easier to understand and kind of follow that code. So that's kind of what this first function call does, is it just does that initialization, gives you back this BLE provider object, and then from that you can call a bunch of different functions to start discovering devices. Now the way this example works is I define a main function, and we'll come back to this, but way down at the bottom, this is actually where the code will start out. And so it calls an initialize function, and again, this just has to go and set up some stuff in the background. And then I call this run main loop with, and I pass it a function, and so I'm actually passing it a link to this main function. And like I said before, a lot of the Bluetooth libraries, like even on Mac and on Linux, they actually run as like a GUI program. So even though there's no window or anything being displayed, they're calling functions that mean you have to have a message loop in the background that's listening to events that the operating system is telling you. Typically in a GUI, like you have a graphical interface, and it'll call functions that are events of like, hey, somebody clicked on your window or somebody clicked a button. But in this case, there are certain events from Bluetooth, Bluetooth Low Energy, things like you received a new characteristic value. And so that means you have to have this message loop in the background. And there are a couple ways to do this. The simplest way is to just say, okay, create a thread in the background, let it run the message loop, and then here's my function, and go run my function in its own thread. And that's what this function does here. So we're just saying, go run a main loop. I don't want to know the details about that, and just make it work, and then call my custom code here. And so that's where my main function will go. And so it starts out at the top here. And so I call this clear cache data function, and this is just as you work with blues and some of these libraries, you realize, it's not necessarily a bug, it's just they work in different ways. And so blues caches a lot of data, which means it remembers the state of devices that it's seen before. And if you're changing a device, like if I'm creating a Bluetooth device, maybe I add a new characteristic to it, blues might have cached an old version of that device. And so this function just says just blow away all that cached data. And Mac OS X has the same problem too with core Bluetooth. And so this just solves a lot of trouble where you might connect and you're interacting with a device and it doesn't have the data you expected because it's using this older cached version. So I'm just explicitly saying, hey, start with a clean slate here. And then I say, okay, now I have to get my Bluetooth adapter. And so this is like from the very first video, when I use that HCI or the Bluetooth CTL tool, you have to power on your adapter. And so that's what this code does. It's just calling a power on function to make sure that my adapter is turned on. Then I call this disconnect devices function, and I pass it my UART service UUID. And so this will actually check and see, am I already connected to a UART device? And if so, disconnect from any of those. Because this makes it easier to rerun this program. Like if the program crashes and the connection stays to the UART device, then the UART is going to actually still be connected to my computer. It's not going to be advertising its presence. So this is just to make sure that I'm starting from a clean slate. Just forget any connection and just start over effectively. Then the next block of code will look for a UART device. And so it starts scanning on my adapter, and I call this little find device function, and I pass it a service UUID. So I pass it the UART service ID, and I say, okay, look for a device that advertises the UART service. And by default, it's going to wait 60 seconds, and you can change that timeout. And if it finds one, it's going to return and give you that device back. If it doesn't find one, it's going to give you nothing back, and you just need to fail at that point and say, oh, I couldn't find my device. But once it finds it, then it wants to stop scanning, and then it's going to connect the device. And this is going to wait 60 seconds, and if it can connect after 60 seconds, it's going to continue on with your code. If it can't connect, then it's going to throw an exception. And here you start to see where, I've turned this into more procedural code. So like in the Noble library, this is asynchronous. So you call connect, and you'd have to pass it a callback to say, okay, once you're connected, now call my function. But in this case, I simplified it and said, okay, my connect function is just going to wait. It's going to do nothing. It's going to spin for 60 seconds and wait and see is it connected. But once it connects, then it's going to finish and return back to your code. And so you can see how this is much, much simpler. I don't have to have this long chain of callbacks here. It's not necessarily better. Like the Noble code is going to be more efficient because, while you're waiting that 60 seconds, your code could go on and do other things. Like, you could talk to like Wi-Fi devices or do all kinds of things. But for just a simple example, I like this kind of style, this very procedural, step-by-step style. A lot easier to understand this code. So now I start out and I have a try block because I want to make sure that if something crashes, I want to disconnect and try to gracefully close that connection. But once I've connected, then I need to kick off the service discovery. And so I have a discover function, and I'm passing in a list of service UUIDs and characteristic UUIDs. And so this discover function is going to try and wait for the discovery of the services and the characteristics that I pass in. So as soon as it can discover just these services and characteristics, it's going to return back and just keep going with my code. It's going to wait like up to 60 seconds. And again, you can tweak all these timeouts. There's a timeout second parameter you can pass in. And again, it's procedural. You don't give it a callback. It's just going to do its thing. And if it works, your code's going to continue. If it fails, it's going to throw an exception. So once it works, once it continues, then I call this find service function. And I say, okay, now give me a reference to that service that I waited to discover. So like the UART service, for example. And then once I have a reference to the service, I can call a find characteristics call on it to say, okay, find my RX characteristic and find my TX characteristic. So I can get a reference to those characteristics. And again, this is, behind the scenes, it's actually asynchronous. Like it's getting this data, it's waiting for it, but you don't really have to know about that logic. And now in this example, it just shows a simple example of like writing a value out. So saying, okay, hey, I'm going to write to this transmit characteristic, and then it's going to receive some data. So it's calling this start notify function. And this says, okay, subscribe to changes on this characteristic. And when something changes, now call a callback that I defined. And so that's what the start notify does. And you pass that callback function. So up here is where I define that function. And it's just saying, okay, when I receive data on this from this UART device, just print it out basically here. So then it's just going to wait for 60 seconds and you can receive data here. When it's done, it's just going to call disconnect and finish here. So you can see how this code is a little bit easier to follow. You just see step by step, connect, find the devices, connect to the device, discover the services, get the characteristics in the services, and then interact with the data on the device. So what I want to do is just take this example and let's modify it slightly so that we can read the data from our custom DHT service. And I'll show you it's really not much that we need to change here. So I'm just going to copy all of the code here, and we're going to make a new file in here. So let's make a DHT read.py. And we'll just start with that UART example as a base. Now I'm going to need to change my UUIDs because these are custom to my service that I created. So I'm going to copy out of here the UUIDs. So like here's the service UUID. So we'll copy this out. And for the Python UUID class, you have to put it in this format. So I'm just going to get rid of all these dashes and just delete all of those. And then I have to go in and just manually put these dashes in. So oops, we'll make this look like the other. And then let's copy out the other UUIDs so that make sure I've got the right values here. And we'll change the name of these also in just a second. I just want to get the new values in here. Really handy thing if you use the Atom text editor, Control D, that's what I'm doing right there. If you select something and you press Control D, like if I select this UUID here, I can press Control D. That's going to go through your document and highlight all the instances of that. And you can actually edit these in line. Like if I want to add something in front of here, I can do that. So very, very useful command. Most text editors have a command like that these days. Like I know Sublime Text has a similar command for this. So easy way to just wrangle a lot of text in different ways for this. So use that. It's probably the most used command that I use in the Atom text editor here. So okay, that's that UUID, and then let's just do the last one right here for the humidity characteristic. So we'll drop this one in and then just get it in the right format real quick. So get rid of all these dashes. Uh-oh, I went too far. Let me make sure I don't delete a dash I didn't expect to. So go through and just get the very last one. All right, that, and then let's put in the format. And if I don't have these dashes here, unfortunately, the Python UUID class will explode and not work. So I've got my UUIDs. Now let's change the name slightly. Instead of UART service UUID, let's change this to DHT service UUID. Again, I'll use that Control D because this is really useful. I'm just going to go through and this is going to select every instance of this, and then I can just rename them all at once. So we'll say, okay, here's my DHT service UUID. So easy way to make sure you don't miss or forget, changing one of these values. Let's do the same thing for the TX characteristic. So this one is the temperature characteristic, if I remember correctly. And then the other one is the humidity characteristic. So we'll select all of these. We'll say humidity characteristic UUID. So okay, so we've got my UUIDs here, and let's make these a little bit prettier. And then the rest of the code, we're going to keep it pretty much the same. So same setup, same initialization, power on, disconnect from any DHT device we currently might be connected to. Now in my find device, I'm going to change this slightly. So right now, the way it's set up, it's passing the service UUID, so it's passing a list of service UUIDs to look for in the advertisement of a device. Now I did not configure my device to publish or to advertise the service UUID. I could do that, but I just wanted to show a different way to call this. So you can actually pass in the name of a device here. So I can pass in a name, and I can say, let's look for my Bluefruit DHT device, because that's the name that I set when I called that get dev name function here. So I'm going to look for this name. So it's just a handy way. You know, there are multiple ways you can find devices. So you can look either for an explicit service that's advertised, look for a device. I think you can even look for the advertised address of a device in this case. So we'll look for it by name, and then let's actually just change all the references to UART in the comments here. For example, we'll say DHT device. So okay, so we connect. And then, yeah, so we do the connection just like before. Now in the service discovery, we're going to look for the DHT service and then the two characteristics, the temp and the humidity, just like before. And so, you know, I did that name change, and so it picked all those up, so I don't need to change that. Now down here, I'm going to find my DHT service, and instead of calling it UART, let's rename this to DHT. And then I'm going to find my characteristics, so, and let's just change these. So we'll call this humidity, and then we'll call this one temp. And now in my code, I'm not going to send any data because, you know, this is just a read-only characteristic. So I'm going to delete this part that writes a value to it. But I'm going to make two functions. So let's make a received temp, and we'll have this print the temperature. And we'll put an F here. This is in Fahrenheit. And then I'm just going to copy this, and we'll do a new function to receive the humidity. So we'll do received humidity. And we'll put humidity here. And then let's put a % after this because it's in percentage, percent of humidity. So, okay, so we've got the two functions. And then now I want to subscribe to, we'll say, DHT characteristic changes, and now I want to subscribe to these, so I'm going to call that start notify, and I need to do it for the humidity sensor, so this will call the received humidity function, and then I'm going to copy this and we'll do it for the temperature also. So we'll say the temperature characteristic, so temp, and then call the received temp function. And let's just keep this. We'll just have it wait 60 seconds and read the data for it. So I'm going to save that, and then let's go back to the Pi, and I'm in that examples directory here. And let's run sudo python dhtread.py, and let's see what happens. So this is using the Raspberry Pi. So you can see it's searching for devices, and okay, cool, look at this. So it looked for the device, and then it found it, and it found it based on its name. So remember in the code up above, we're looking for a device with Bluefruit DHT as the name. It discovered all the services, and then it subscribed to changes on the two characteristics. And now you can see it's printing out the values. So I'm going to blow on the sensor, and we should see that it jump up in values. So yeah, so now humidity is up to 75, 83%. So that's pretty cool. Like, we've written some Python code. It's not too crazy. Like, you know, this library tries to hide a lot of the complexity behind the scenes here. You know, it's using the dbus interface to the Blues library, and it's reading the state of these characteristics. And so you can see, you know, my code, I could make this a lot more complex. Like, you know, instead of printing this value out, I could maybe, you know, have maybe like a web page that the Raspberry Pi exposes, and, you know, I could have a whole web interface that's publishing this data. You know, maybe I have sensors all around my room and my Raspberry Pi reading that data. And so you can see it just finished. It ran for 60 seconds here. But this is pretty powerful. I mean, we've created a custom Bluetooth device. We've written some code that we receive the data from that device here, and, you know, it's not too crazy to get this going. I do want to say this Python library, I still kind of consider it beta. Blues in particular, you know, you have to run it with that experimental flag. It can be a little flaky. You know, there's sometimes things fail in weird ways. So I'm not super comfortable in saying, like, this is perfect, go for it, you're not going to have any problems. But it works pretty well, you know, if you keep the usage pretty simple like this. And I think over time, as Blues improves and has, you know, more releases and things, and maybe once they take the Bluetooth low energy stuff out of that experimental flag, you know, maybe things will get a little more stable with it. But so far, it seems like a pretty good way to you know, to receive this data. Now I could go and I could use the Noble library, and I could write code that reads my DHT device, the service and the characteristics there. You know, again, this is all just generic stuff. As long as you know these GUIDs, then you can connect to my device, you can read that data and get it. So that's one of the really powerful things with Bluetooth Low Energy, that you can define these custom services and characteristics, and then anything can read that data for it. So I think that's all that I wanted to show for this stream. Real quick, if anyone has questions, maybe fire them off in the chat. And let's see, we'll cut back to the main kind of view right here. And I think I'm going to consider this the end. So we'll say this is a 3-part series on Bluetooth Low Energy with the Raspberry Pi. I'm certainly going to do a lot more Bluetooth Low Energy stuff in the future, but I just wanted to do a good series of videos. So just to kind of recap those, the first video in the series was like an introduction to Bluetooth Low Energy and the Blues library, which is what you can use to talk to Bluetooth Low Energy devices on the Raspberry Pi. So I show how to compile and install it, and get the very latest version of it, because it changes pretty frequently, and the version that's in the repository for Raspberry Pi might be out of date. Then the second video, I showed how to use a Node.js library called Noble to interact with Bluetooth Low Energy devices, and great library. It works on Windows, Mac, Linux, pretty stable, very full-featured in my usage of it. And so if you're familiar with JavaScript, that's a great way to get going and start using Bluetooth Low Energy. And I also showed the little Bluetooth Low Energy application that I created, the Bluetooth Low Energy desktop app that lets you connect to a device, look at the characteristics and services, that app is actually using the Noble library internally. And then in this video here, I showed how to use a Bluefruit device, in this case the Feather M0 Bluefruit, how to create a custom service and then custom characteristics. So I'm effectively creating my own Bluetooth Low Energy device, and then just set characteristic values like a DHT temperature, humidity sensor here, publish that data with Bluetooth Low Energy. And then I showed how to use a little Python library that uses Blues on the Raspberry Pi, and it uses kind of the dbus interface that Blues exposes to connect to a device, find that custom service, find those custom characteristics, and then receive that data from the device. So prints out, here's the temperature and the humidity for it. So I'll look real quick. I don't see any questions. So I think I'll wrap it up then. So, subscribe to Adafruit's YouTube channel, and you can see this video and lots of other cool projects and things. Subscribe to twitch.tv/Adafruit, and you can be notified when I do live streams like this in the future. So I'm trying to do things every Friday, have like an in-depth live stream, and then Mondays I'm thinking about doing just maybe more general stuff. So like Monday this week, I looked at emulators on the Raspberry Pi, and that actually turned out to be a pretty popular video. So definitely check that out. I'll put a link in the description below if you're interested in running like video games and things on the Raspberry Pi. So thanks a lot for watching, and tune in next week, and I don't know, we'll see. We'll have to do something new and fun. We'll take a break from Bluetooth Low Energy and see what's out there with the Raspberry Pi. So that's it for now. So thanks for watching.